Good morning, students. My name is B. Padmaja, working as an assistant professor in the Department of CSC, Vignan Institute of Engineering for Women. Today I am going to discuss about CPU scheduling algorithms. Before going to CPU scheduling algorithms, we have to know about process. So what is process? Process is nothing but a program in execution. Program is a passive entity, and whereas process is an active entity. So scheduling. So CPU scheduling means it is an activity by the process manager to remove a process from the CPU and to allot a new process to the CPU. So CPU scheduling algorithms, in CPU scheduling algorithms, we may mostly the main objective of this CPU scheduling algorithm is to switch processes among themselves. So CPU scheduling algorithms takes place when a process switches from running state to waiting state, and a process switching from running state to ready state, when a process switches from waiting state to ready state, and when process terminates. Actually, there are 5 states in a process. First one is new state. Second one is ready state. Third one, running state. Fourth one, waiting state. Fifth one, termination. So first state, new state. When a process is created newly, then that will be entered into new state. Next one, second state is ready state. So ready state is when a process is ready to execution in its memory, so it will be in ready state. Next, running state. Running state means when a process enters into execution, that is called as running state. Next, when a process is waiting for the when a process when a process is occurred by some other IO interrupts or IO events, then it will enter into waiting state. When a process completes its execution, then it will be terminated. So totally there are 5 states. So when a process switches from running state to waiting state, that means when a process interrupted with some IO interrupts or IO events, then the process will enter into waiting state. Then process switches from running state to waiting state. Second one switches from running state to ready state. When a process is interrupted by some other interrupts other than IO interrupts, so that then process will enter into ready state from running state. Next, switches from waiting state to ready state. So process after completing its IO interrupts, the process will enter into ready state again. So when process switches from waiting state to ready state, then also CPU scheduling will occur. Next, after when a process terminates, when a process completes its execution completely, then the process scheduling is occurred. That means another process will enter into execution. So these are the 4 situations. So mainly there are 2 types of schedulings. First one is non-preemptive scheduling, second one is preemptive scheduling. In non-preemptive scheduling is occurred when situation 1 and 4 occurs. So that means when a process switches from running state to waiting state, then it is called as non-preemptive scheduling. And also when process completes its execution and it terminates, then also it is called as non-preemptive scheduling algorithm. At that time, that means non-preemptive is nothing but until a process completes its execution, it will not be terminated or it will not be come out from the execution or CPU. Next, second one is preemptive scheduling. Preemptive scheduling occurred when process switches from running state to ready state, and also process switches from waiting state to ready state. That means when a process is occurred by some other events like IO interrupts or any other interrupts, then that process will be come out from the execution and new process will be allotted to the CPU. So execution is done in the CPU. Next one, dispatcher. So dispatcher is nothing but dispatcher dispatches the processes which are in ready state to the CPU. So if we want to execute one process, that process must be allotted to CPU. So who will help that process? Dispatcher. So dispatcher will select one process from the ready state and will alert that particular process to the CPU. So this involves these three states. First one is switching context, switching to user mode, jumping to the proper location in the user program to start the program. So first one is switching context. So process switching. When a process is switching from one state to another state, so dispatcher involves and dispatcher will allot another process to the CPU. Next one, switching to user mode. When a process is entered into user mode, then CPU will be free. At that time also, dispatcher will allot some other process to the CPU. Next one, jumping to the proper location in the user program to restart the program. So program is executed. So at some point the program is interrupted and terminated from the execution. At that time also CPU or dispatcher will allot one process to the CPU. The main motto of this CPU scheduling is keeps CPU continuously busy. Next one, scheduling criteria. In scheduling criteria, the CPU the operating system will follow these criterions. First one is CPU utilization. So as I told you that the CPU as busy as possible. CPU should not wait for any other processes. So CPU should continuously works on. Next one, throughput. So throughput is nothing but the complete completion of the process execution per unit of time. So the main criterion for scheduling is to maximize CPU utilization and to maximize throughput. That means for a particular unit of time, there must be number of executions, number of processes should execute. Next one, CPU utilization. So CPU should continuously work on. CPU should not wait for any other process. It should not give any time lapses. Next one, turnaround time. The amount of time to execute a particular process. Turnaround time is nothing but the complete execution of a process. Next one, waiting time. Waiting time is nothing but the waiting time of a particular process. So there are number of processes. So initially one process will be executed and other process will have to wait in ready state. So that process waiting time is to be very minimum. Next one, response time. The amount of time it takes from the request and until the first response. So each and every process has to execute in CPU. So first the process will request for the execution. So starting from the request and till execution, the time is calculated as response time. So these three criteria should be minimum. Turnaround time should be minimum. That means minimum amount of time there must be number of executions, number of processes should execute. Next, minimum waiting time should be there. Next one, response time. So that means CPU must respond to the individual processes quickly. So these are the scheduling criteria. Next one, there are totally different there are different scheduling algorithms. First one is CPU scheduling algorithm. First come first serve scheduling algorithm. Second one, SJF algorithm. Third one, priority scheduling algorithm. Fourth one, round robin scheduling algorithm. First one, FCFS. FCFS means first come first serve scheduling algorithm. So all the processes are resides in ready queue. Whenever the process is ready for execution, that process will be allotted to the CPU. So that is first come first serve algorithm. So this is the example for first come first serve algorithm. So there are three processes in ready state, all arrived at time 0. And these are the burst times. That means process P1 can execute in 24 milliseconds and process P2 can execute in 3 milliseconds and process P3 can execute in 3 milliseconds. So these are the execution times for individual processes. So first we have to prepare a Gantt chart. So in that, whatever the process first enters into ready queue or whatever the process first requests for the CPU, that process will be allotted to the CPU. So process P1 is entered into ready queue first. So that process will be allotted to CPU first, and its execution is 24 milliseconds. Second process is P2. P2's execution time is 3. So process P after completion of process P1, then only process P2 will be allotted. So totally there are two types of scheduling algorithms, preemptive and non-preemptive. Preemptive means when a process interrupted with any interrupts, or when a process is when a process got any interruptions in the middle, then that process will be come out from the execution and other process will be allotted. That is preemption case. And in non-preemption, after completion of the process, particular process, it will not be terminated until its execution. So process P1 entered into execution, until it finishes its execution, this will not be terminated. So after this execution, that means 24 seconds, then only process P2 will be allotted to the CPU, and process P2 execution is 3 seconds. So total execution of process P1 and P2 is 27 milliseconds. Next one, process P3 is in ready queue. So process P3's execution is 3 seconds. Then after completion of process P1 and P2, then only P3 will be allotted to CPU. So P3 will be entered into execution and it will execute for 3 seconds. So total execution time of process P1, P2 and P3 is 30 milliseconds. So here we have to calculate. So there are different criteria we have, right? So first one is waiting time. So we have to calculate average waiting time. Next one, turnaround time. So total execution time of all the processes we have to calculate, that should be minimum. And also we have to calculate average waiting time, that also should be minimum. So waiting time for process P1, as soon as it enters into ready queue, it will be allotted to the CPU. So process P1 waiting time is 0. Next, process P2 waiting time is 24 milliseconds. That means process P2 has to wait until process P1 finishes its execution. So that 24 milliseconds is the waiting time for process P2. Next, process P3 has to wait until process P1 as well as process P2 completes its execution. So total execution time of process P1 and P2 is 24 milliseconds. So process P3 has to wait 27 milliseconds to enter into CPU or to allotted to CPU. So finally we have to calculate average waiting time for each and every process. So waiting times are 0, 24 and 27. So waiting time is, average waiting time is 0 plus 24 plus 7 whole by 3. And we also have to calculate turnaround time, total turnaround time. So total turnaround time is nothing but starting from the enter into execution until complete execution of that particular process. We have to calculate turnaround time. So the turnaround time for process P1, the turnaround time is 24 milliseconds, and for process P2 the turnaround time is 27 seconds, and for process P3 it is 30 milliseconds. So we have to calculate average turnaround time. The average turnaround time for 3 processes are 24 plus 27 plus 30 whole by 3. So these are the average waiting time and average turnaround times. These should be very minimum. So there is a problem in first come first serve scheduling algorithm. The main problem is shortest job process has to wait until longest process finishes its execution. So that is the main drawback in FCFS algorithm. To overcome this problem, we have SJF scheduling algorithm, that is shortest job first algorithm. Shortest job first scheduling algorithm. So in shortest job first algorithm, first the shortest execution or the shortest burst time process will be entered into execution, then only longest processes will enter into execution or will be allotted to CPU. So this is the example for shortest job first scheduling algorithm. So these are the arrival times. Next one, burst times of individual processes. So process P1 is arrived at 0.0 milliseconds and its burst time is 6. Process P2 is arrived at 2.0 and its burst time is 8. Process P3 arrival time is 4 seconds and its burst time execution time is 7 milliseconds, and process P4 arrival time is 5 seconds and its execution is 3 milliseconds. So initially in these four, the shortest job process is process P4. So process P4 will enter into execution first. Process P4 will enter into execution. So this is a non-preemptive scheduling algorithm. So until the complete process executes, it will not be terminated. So process P4 first entered into execution and its burst time is 3 seconds. So process P4 will be allotted for process P4 will be executed for 3 milliseconds. Next shortest job is process P1. So its burst time is 6 milliseconds. So next one, process P1 will enter into execution and it will be executed for 6 milliseconds. Next shortest process is process P3 and its burst time is 7 milliseconds. It will be executed for 7 milliseconds. Last process is process P2 and will be executed for 8 milliseconds. So process P4, now we have to calculate waiting time and turnaround times. So waiting time for process P1 is allotted to CPU after completion of process P4. After completion of process P4. So process P4's burst time is 3 milliseconds. So process P1 has to wait 3 milliseconds to enter into execution. Next process P2 has to wait 16 milliseconds for its execution. Next process P3 has to wait 9 milliseconds for its execution. Next process P4 has to wait 0 milliseconds because process P4 is entered into execution first. So these are the waiting times for each and every process. Next we have to calculate turnaround times. Turnaround times are nothing but execution times. So process P1 execution time, process P1 is completed at 9 milliseconds. So turnaround time for process P1 is 9 milliseconds, and process P2 it is 24 milliseconds, and for process P3 it is 16 milliseconds, and for process P4 it is 3 milliseconds. So the average waiting times for each and every average waiting time for 4 processes is 3 plus 16 plus 9 plus 0 whole divided by 4, and average turnaround times for all processes is 9 plus 24 plus 16 plus 3 divided by whole divided by 4. So these are the average waiting time and average turnaround times. So here also we have some problem, that is there is a prior intimation or prior information about each and every process and their burst times. So without knowing their burst times, we cannot, or process operating system cannot enter or cannot allot processes to the CPU, because here the scheduling is shortest job first. So for selecting shortest job process, we have to know the burst times. So the shortest burst time process has to enter into execution. That means operating system should have prior information about each and every process. So that is somewhat difficult. So there is another scheduling algorithm, that is priority scheduling algorithm. So in priority scheduling algorithm, without any previously we have discussed about FCFS and SJF algorithms. So in priority scheduling algorithm, we have each and every process will select processes based on their priorities, not by their first come first serve, or not by their execution times, based on their priorities. That means highest priority process will be allotted to the CPU first, later on lowest priority processes will be allotted to the CPU. So that is priority scheduling algorithms. So this is the example for priority scheduling algorithm. Priority scheduling algorithm. In priority scheduling algorithm, we have 5 processes and burst times and their priorities. So smallest number priority is given as highest priority to the process. Smallest numbers given highest priority to the process. So likewise, P2 is having highest priority, next highest priority process is P5, and next highest process is priority process is P1, next highest priority process is P3, next one is P4. So process P2, so all are arrived at time 0, and their burst times, these are the burst times and these are the priorities. So highest priority process is process P2. So process P2 is having first number 1, priority number 1, that means P2 is having highest priority, so that process P2 will enter into execution and its burst time is 1 second, so it will be executed for 1 second. Next highest priority process is process P5 and its burst time is 5 seconds, so it will be executed for 5 seconds. So total execution time is 6 seconds of process P2 and P5. Next highest process is P1 and its burst time is 10 seconds, so total 16 seconds is allotted for process P1, P2 and P5. Next highest priority process is P3. P3 will be entered into execution and it will be executed for 2 more seconds, 18 seconds. So finally process P4 is the least priority process, that will be entered into execution, and P4 is having 1 millisecond execution, 1 millisecond for burst time. So total 19 milliseconds will be allotted for the completion of execution process P1, P2, P3, P4, P5. So now we have to calculate average waiting time, same waiting time. So waiting time for process P1. So process P1 has to wait 6 milliseconds because in prior process P2 and P5 is having highest priority. That's why until their execution, it will not be entered into CPU. So it will not be entered into execution. So it has to wait 6 milliseconds. Next process P2 waiting time is 0 seconds. So because it is having highest priority, so its waiting time is 0, and process P3's waiting time is 16 milliseconds and process P4 waiting time is 18, and for process P5 it is 1. So average waiting time for 5 processes is 6 plus 0 plus 16 plus 18 plus 1 whole divided by 5. And now we have to calculate turnaround times. Turnaround time is complete execution of process P1. P1 execution is 16 milliseconds and P2 execution is 1 second. And P3, for P3 it is executed in 18 seconds, and P4 it is executed in 19 seconds. P5 it is 6. So average turnaround time is 16 plus 1 plus 18 plus 19 plus 6 whole divided by 5. So these are the average waiting time and average turnaround time for priority scheduling algorithm. And last one is round robin scheduling algorithm and non-preemptive scheduling algorithms. So in round robin scheduling algorithm, there is a time quantum. In that time quantum, each and every process will execute and will terminate from that execution, and it will be given chance to some other process. So this is the example for round robin scheduling algorithm. There are totally 3 processes and 3 burst times. So here the time quantum is 4 milliseconds. Here the time quantum is 4 milliseconds. So process P1 will be entered into execution first, and it will take 4 minutes time to execution. So in 24 seconds, 4 seconds it will be executed first. Next it will be given chance to process P2, and process P2 burst time is only 3 seconds, so it completes its execution completely. Process P2 will be executed completely. Next process P3 will enter into execution and it will complete its execution for 3 seconds. So next one, process P1. After process P3, again the chance will be coming to process P1, and process P1 will execute for 4 more seconds because its time quantum is 4 seconds. So from 10 to 14 seconds process P1 will execute. Next Remaining, so here the process P1 is executed for only 8 seconds and remaining it is having 16 seconds, 16 milliseconds. So next also process P1 will enter into execution and it will be executed for 4 more seconds. Next also process P1 entered into execution, it will executed for 4 more seconds till process P1 burst time is completed. Until then process P1 will be executed in its execution state. So this is a round robin scheduling algorithm. So these are the preemptive, non-preemptive scheduling algorithms. Preemptive scheduling algorithms we will discuss in next class. Thank you.